So we're going to talk more about logarithms today. We're going to talk specifically about the properties of logarithms. And this section is one where we have to do without a calculator, right? So no calculator for this section. Okay, so remember way back in the day when we have x cubed times x to the 5, right? How much is that? That's x to the what? X to the 8, because we do 3 plus 5, and we get x to the 8, right? So, when we're multiplying powers, the exponents add. Is that right? Now, what is a logarithm? It's just a what? An exponent. That means here, right? So let's look at the product property of logarithms. If I have log mn, this is asking me, this is saying what is the exponent of these two things multiplied by each other. So just like here, what is the exponent of the x cubed and the x fifth when they're multiplied by each other? Well, the answer is, what do you do to the exponents? You add them. So you add the exponent of the first one plus the exponent of the second one, right? So the first part is asking, what do you know about the exponents of two things that are being multiplied? The second part is saying you take the exponent of the first one, you take the exponent of the second one, and you add them, right? So that is the product property of logarithms. All right, so let's take a look at this first one. It says to use the product property of logarithms to expand each logarithm. That's the terminology. It says to expand. So what we're going to do first is we're going to say, how many elements are inside this log? 2. I have a 3 and a 5. 1, 2. Because they're being multiplied, I say log the first one plus log the second one. Okay? And so now, there were 2 elements in here, and how many logarithms did I end up with? 2. Okay? All right, let's do one more here. How many elements inside? A 5 and a 7, that's 2. So I have log 2 of 5 plus log 2 of 7. All right? Okay, next. How many inside the ln? 1 and 2. So it's ln of the first one plus ln of the second one. Okay. Next, I have log 2, 5ab. That's 3 things inside that are being multiplied. So it's log 2 of 5 plus log 2 of a plus log 2 of b. 3 elements, 5ab, 3 separate logarithms. Okay? So often a student will think, for example, 4x is just one thing. They're so cute together that we don't think to separate them. But no, you have to separate them. Or here, very commonly a student will say log 2 of 5 plus log 2 of ab. You don't separate the ab, but you have to. All right, next one. I have 3 terms again, so tell me what I'm going to get here. Log base 4 of
3
log
base 4 of x.
Yep.
Plus log base 4 of y.
Yep. That's all. Questions? Okay. Next one. Now I have a root. When you have a root, you have to rewrite it. So I'm going to rewrite this as ln 5 x to the 1/2. Now, I've got 2 things in here, right? So I'm going to expand like ln of 5 plus ln of x to the 1/2. Now, we're going to leave it like that. It's not really completed just yet, but at the end of the lesson, we're going to come back and complete that one. Okay? All right. Let's move on to a different situation. What if you're asked to express a logarithm in terms of two different logarithms? For example, we want to express log of 12 in terms of log 3 and log 4. Okay? So what you do first is break down the constant into smaller numbers which multiply to the original. So, how is 12 related to 3 and 4? Well, it's just 3 times 4, right? You can do 2 times 6 as well, obviously, but it's asking you log 3 and log 4, so you have to do 3 and 4. Next, so log 12 is log 3 times 4, right? Now I can expand it. So log 12 is rewritten as log of 3 times 4. So this is log of 3 plus log of 4. Okay? All right, let's do one here. Log of 6, right? We have to express it in terms of log of 2 and log of 3. So let's do log 6. 6 is what? 2 times 3. So this is log 2 plus log 3. Okay, you know what? I'm going to change the other one. I'm going to, okay, so it says express in terms of log 5 and log 3, but instead of the 45, I'm going to make, I'm sorry, instead of the 15, I'm going to make it a 45. Just, spice it up a little. Okay, so I need to write 45 in terms of 5 and 3. So here's what I do. I take the 45 and I break it down, right? What's 45? It's what times what? 5 times 9. Now I want to, break it up into 5s and 3s. So let's go a little bit more. 3 and 3. So finally 45 is 3 squared times 5, right? Yes. So this is going to be log 3 squared times 5. And when I expand, log 3 squared plus log 5. Yep.
Could you do log 3 plus log 3 plus log 3?
Yeah, you can do log 3 plus log 3, but then it'll be 2 log 3. Right? Yeah, and we're going to come back to this in a minute as well and simplify a little more. Okay, so let's talk about quotient property now, right? Okay, so suppose you have x to the 7 over x to the 4. What is that? X to the what? What do you do to the exponents?
Subtract.
7 minus 4, subtract. So, if this here is asking you, what is the logarithm of m over n? So what is the exponent when you're dividing two things, right? Well, the exponent is you take the first exponent minus the second exponent, right? So here, if I were just asking you what is the exponent in this operation, x to the 7 over x to the 4, the exponent is 3. You do 7 minus 4, 3. So that's what this is telling you. So when you have the quotients, you have to subtract the logarithms. All right, so here I have ln of 3 over x. That's going to be ln of 3 minus ln of x. How many terms in 3 over x? 2 elements, 2 logarithms. Everything in the denominator gets a minus sign. Okay, let us rewrite this first. Log base 3 x to the half over y. So this is log base 3 x to the half minus log base 3 of y. Okay? So, summarizing, each element in the numerator is added, and each element in the denominator is subtracted. Okay, so look at this one now. How many elements total do I have? 1, 2, 3. Okay? Now, the ones on top are going to be plus, plus. The ones in the denominator, minus. So, I do log 3. Start with the first one on top, 2. Next one is the a. That's on top, it gets a plus. Log 3, a. Next, it's on the bottom, minus log 3, b. Cool? Yeah? All right. Okay, next one. How many elements? 1, 2, 3, 4. So, log 2 of 5 plus log 2 of x. Okay, now everything in the denominator gets a minus. Minus log 2 of 3 minus log 2 of y. All right, I'm going to give you 10 seconds to do the next one. Yep, ln of 2 plus ln of r minus ln of t. Okay, last but not least, power property. If you have a power in the log, the power comes down and it becomes a coefficient. Okay? So, let's expand these ones. I have a power here, comes down. So I get 2 log x. No. I hate that snail thing. Okay, so interestingly, we learned where you use that snail method, but we never used it, and you never even needed a...
Didn't you teach us it last year? No?
That wasn't me. No. Okay, here, look, 2 elements, 1, 2. So I gotta do log base 3 x squared plus log base 3 y squared. Now what happens? 2's come down. So 2 log 3 of x, 2 log 3 of y. Alright, that's the first thing I'm going to do for C. Yep, x to the half. Then, half comes down, half ln of x. Next, okay, now I have a 3 out front. So whatever I do has to have a 3 in the beginning. So what I'm going to do here is 3 times, now expand, log 2a squared plus log 2 of b. Then, okay, often students will say, okay, we're done. But what have we not completed yet? The exponent has to come down. So this is 3 times 2 log 2a plus log 2b. Now, that will give you a complete credit, full credit. If you want to distribute the 3 and make it 6 log 2a, 3 log 2b, that's also okay and full credit. But the step above, that first step, barely half credit. Yeah? Okay. All right, look at this next one. Log base 2, 32 to the half. Yeah? Let's move the half down. Whoops, moving the half down. But now, anything we can simplify here? This is a half. What's this mess equal to? What is the exponent of 2 to give you a 32? A 5. Yep. So that is 5 over 2. 1 times 5, and that's 5 over 2. 1/2 times 5 over 1. This whole thing is just 5. Yeah. Okay. Here, 3 log 7, and then 49. Hey, look. 49 to the 1/6. Yes? 1/6 will come down. So I have 3 times 1/6 log 7, 49. That's 1/2. And how much is this? 2. And together that's 1. Who would have thought this complicated thing is just equal to 1? Right? Plot twist. Okay. Here we go. What's going to happen here? 4 comes down. So I have 4 times 3 ln of e minus 2 comes down. 2 times 2 ln of e. So this is 12. But what's ln of e? 1. Minus 4. 1. So that's just 8. Could we have done it the way we were doing it yesterday? Right? Remember yesterday we said ln of e is, well, ln of e to the 4 is just 4. 3 times 4 is 12. Right? So 2 ways to do it. Okay, let's summarize. How do we do this business? How this expanding? Oh, wait, before I summarize, let's get back for a minute. Go back to example 4, part B. This one, I used the quotient property, but I haven't completed it. What else do I need to do?
You need to add the 1/2.
Bring the 1/2 over.
Yeah.
So this is 1/2 log 3 of x minus log 3 of y. Where else? Let's go up. Ooh! Another one here.
2 log.
Yes. So what you were asking Max before was if you can do log of 3 plus log of 3 plus log of 5, but then that'll be 2 log 3, and same deal here. Yep. So where else? Look at F here. This one. It's ln of 5 plus 1/2 ln of x. Okay? Okay. So the homework for this is another handout.